All right, let's dive into a really cool scientific detective story. It starts with some dusty old photographs of the night sky and ends up right in the middle of the Cold War.
So, here's the mystery we're unpacking today. Is it possible that all those atmospheric nuclear tests back in the 50s left some kind of ghost, not on Earth, but up in the night sky? Okay, so to get into this, you need to know about something called astronomical transients. It's a fancy term, but the idea is simple. Imagine a flash of light shows up on an old photo of the stars, but when we look there now with our modern telescopes, poof, it's gone, a phantom signal. The scene of the crime, so to speak, is this incredible archive, the Palomar Observatory Sky Survey. We're talking about a huge collection of glass plates that mapped the sky between 1949 and 1957. And on these plates, researchers found, get this, over 100,000 of these weird, unexplained flashes. For decades, nobody knew what to make of them.
So where do you even start with a mystery like that? Well, the first big break came when scientists did what good detectives do. They looked for a pattern. They started lining up the dates of these flashes with major historical events from that time.
And what they found was kind of mind-blowing. A recent study revealed a real, statistically significant link. It turns out that on the very same days the US and the Soviet Union were testing nuclear weapons in the atmosphere, more of these strange flashes were popping up on the photoplates.
Now, for the data nerds out there, the connection had a strength of 2.6 sigma. So what does that mean? Basically, there's only about a 1 in 160 chance that this is just a random fluke. It's a really strong clue, right? Case closed? Well, not quite.
Just when it looked like we had our culprit, a new suspect entered the picture. And this one is a lot bigger, and it's about 93 million miles away. We're talking about the sun. You see, the sun is always throwing charged particles at us. Sometimes it gets really intense, and we get what's called a geomagnetic storm. It's basically a major disturbance in Earth's magnetic field, and scientists have this handy little scale, the KP index, that goes from 0 to 9 to measure just how stormy space weather is.
So the next logical step was to see if these solar storms had any effect on the flashes. And when they checked, wow. What they found was a total curveball. It seemed to flip the whole theory on its head.
And this chart really lays out the twist. You think a giant solar storm might cause more weird flashes, right? Wrong. It was the complete opposite. On quiet days, about 17% of the photoplates had these transients. But during the most intense storms, that number dropped off a cliff, all the way down to just 2.4%. It's like the storms were making them invisible.
So now we have a huge puzzle. How can a nuclear bomb create these flashes, but a massive solar storm, a much bigger event, makes them disappear? It just doesn't add up. Did this mean the whole nuclear connection was just a wild goose chase? To crack this, the scientists had to figure out how these two things, nuclear tests and solar storms, were related. So they asked a really smart question. Back in the 50s, were the military specifically waiting for calm, quiet space weather days to set off their bombs? And the answer, as you can see here, was a big nope. Actually, it was the opposite. Days with nuclear tests were slightly more likely to have geomagnetic storms than your average day. They weren't avoiding the storms at all.
And that was the aha moment. It all clicked into place. Think of it like this. The nuclear tests were definitely creating a signal. They were causing a spike in these flashes. But since the tests often happened during stormy weather, the solar storms were acting like a fog or a mask. They were hiding the very signal the tests were creating, making the connection look way weaker than it actually was.
So what happened when they built a new model that accounted for both things, the bomb signal and the solar storm mask? Well, the connection didn't just hold up, it got stronger, way stronger. It jumped from 2.6 sigma to 3.1 sigma. The storms weren't the problem, they were just hiding the proof all along.
Okay, so the puzzle is solved, but what does it all mean? What in the world are these things?
Well, the fact that they react to solar storms is a huge clue. It tells us this isn't just some random flaw in the camera film, and it's probably not just a piece of space junk floating by. Whatever is causing these flashes seems to be physically tied to Earth's own magnetosphere. Maybe it's some kind of phenomenon happening up in the radiation belts way above us.
It's just like the lead researcher Kevin Can said. The solar storm data, the KB index, was the missing piece of the puzzle. Once they included that extra variable, it removed the masking, and the real connection popped right out. It's a perfect example of how one thing you're not measuring can completely hide a major discovery.
So the big takeaway here is how science works, right? It's all about refining our understanding. What started as one weird correlation has been tested and retested, and now we have 3 independent analyses, all looking at the same old data and all pointing to the exact same, pretty incredible conclusion.
And that just leaves you with this amazing thought, doesn't it? This whole discovery came from looking at 70-year-old photos with a totally new set of eyes and new data. It really makes you wonder, what other huge discoveries are just sitting there, hidden in dusty old archives, just waiting for someone to come along and ask the right question?